Hello friends, welcome to Coding Garden with CJ. Tonight is Code Katas number 4, the show where I solve code katas live in front of you, and yeah, that's pretty much what happens. I have an intro song for you. It's a new version of the intro song that I did last time. Okay. Well, we're gonna break things down one step at a time. We're gonna solve these katas, you and I. We're gonna break things down one step at a time. We're gonna solve these katas, you and I. Code Wars, Code Katas, Code Wars, Code Katas, Code Wars, Code Katas, yeah! Okay. Welcome to the stream. If you're watching live, please throw a message in the chat. Excuse me. Let's get right into this. Welcome Dauber, welcome Joe, welcome Chad. Anyone else, if you're joining live, please say hello. So I do have a GitHub repo. It's github.com/codinggarden/code-katas. And there's an issue on here where you can suggest katas for me to solve. We did have some suggestions come in. Chad, who's in the chat right now, he did suggest one, so I'm gonna give a crack at that one. And then Cassandra Goose, who I actually used to work with, and I used to work with Chad too, suggested several of them. I think I'm gonna attempt to do all of them, but they're a bit harder than the ones I do normally, so we'll see what happens. So I do have, I think 6 katas picked out. The first one, super easy one, it's a 7Q. It's just a basic filtering of a list. And then this is the one that, one of them that was suggested by Cassandra. This is a 6Q. You count the smiley faces. So given an array of things, you have to tell how many of them are actually smiley faces. Then there's scramblies, which was also suggested by Cassandra. You're given 2 strings, and you have to say if the first string has all of the letters of the second string. So if the first string is like a scrambled version with maybe extra letters of the second string, you return true. If not, you return false. Then there's human-readable-time. So you're given an amount of seconds, and you need to return a string that gives hours, minutes, and seconds. It's going to be tricky. And this is the one that was suggested by Chad. This is 5Q, the maximum subarray-sum. So you're given an array of numbers, and you need to return what is the maximum sum of any subarray inside of that array. So for instance, like a subarray here would be -2 and 1, -2, 1 and -3, 1, -3 and 4. And so essentially you need to figure out which subarray has the largest sum and return that sum. So this is also a tricky one. And then this very last one on the surface seems easy, and I did like a quick attempt of it, but then I realized why it's actually pretty tricky. And this is a 4Q. You're given 2 numbers as a string, and you need to return their sum as a string. And where this gets tricky is with really, really large numbers, because if you just convert these numbers, like with the built-in number constructor, and you try to sum them, you'll get like a, mathematical notation, so you won't get the full number. So where that would break is with really large numbers. So we're actually going to have to implement addition with like carrying numbers. I don't know. It's going to be fun. I have an idea how we're going to do it. I don't know. But let's get right into this. As I mentioned, if you're watching live, please throw a message in the chat. Let's get started. Okay, so this first one is called list filtering. In this kata, you will create a function that takes a list of non-negative integers and strings and returns a new list with the strings filtered out. So you're given an array that has numbers and strings inside of it, and you want to return a new array that only has numbers inside of it. So let's try it out. You can absolutely solve this with a filter. That's why they call this filter list, but I'm going to solve it with a for loop first, and then I'll show how you would solve it with a filter. But first, you would need a place to store the filtered results. So a place to store filtered results, and then we would iterate over the array, and then we'll say if the current item is a number, push into filtered results, and then lastly we will return the filtered results. Cool. Okay, so a place to store the filtered results, we'll just create an array called filtered, and then we'll need to iterate over the array. I don't like that they gave this a single letter variable name, so let's call this items. And we'll create a for loop that goes from 0 to the end of items, so items.length, increment I each time. And now we do the check. So if the current item is a number, and I'll store this in a variable, so let's say current item is items at index I, and we'll say if current item is a number. So you can use in JavaScript, there's the type of operator. So you can say if the type of the current item is number, then we will push into the filtered results. So filtered.push current item. And let's just go take a look at type of on Indian. The type of operator. So if you do like type of that, you'll get a number. Type of a string, you'll get back string. Type of a boolean, you'll get back boolean. Type of something that's not defined, you'll get undefined. And I believe arrays and objects, we can just check it real quick. Type of array is actually object, and type of object is object, and type of like a function is, wait, might have to fully type out a function. Type of a function is function. It's good to know. But that should work for what we need, because basically if the type of is number, then we'll put it into the array. And then lastly, we will return the filtered array. Okay, let's see if this works. And if this works, then we'll actually use a filter. Sample tests. That worked. Let's do it with more examples. Cool, that worked. So let's see this exact same function, but using the built-in filter function. Let's do this. Create a file. We'll call this, what are we doing? List filtering.js. And we're going to do this again, but this time we're going to use a filter. So the way a filter works is instead of having to define array, a filter is going to return a new array. So here's what we'll do. We'll just return items.filter. And then filter accepts a function that's going to get called on every item. And so we could call this the parameter current item. Let's take a quick break. For whatever reason, I have decided to drink yerba mate this late at night. 120 milligrams of caffeine per bottle. We're solving katas. I don't know. Okay, so we're going to filter over the array. We can call each item in it current item, and then this will be a function. And the way a filter works is you return true if you want that item to be in the new array. So essentially, this condition is what we want to return. So we'll say return type of current item is a number. And that is all we have to do. Because if the type of is not a number, it'll be false, and that item won't show up in the new array. And if it is a number, it will show up in the new array. So this is the exact same thing, but instead of doing it with a for loop, we do it with a filter. Sample tests. That works. Attempt. That works. Full attempt. And just for the fun of it, we did it. First one down and done. Oh wait, do I have to click submit final? I thought I clicked submit final. Oh well, great. We got that win under our belt. Let's move on to some harder problems. Okay, so this next one, count the smiley faces. So, yeah, given an array of faces, you want to return the number of smiley faces in that array. Rules for a smiley face. So eyes can be marked as either a colon or a semicolon. Faces can have noses, so either a dash or a tilde. And then we only want smiling faces, so the last thing should either be a closing parenthesis or a capital D. No additional characters are allowed except for those mentioned. So some examples of valid smiley faces are these. and invalid smiley faces are these. Cool. Let's copy these rules. We'll put them as comments. I can think of a few different ways to do this. Like, one way might be to create every possible smiley face and then just check to see if each element in the array is one of the possible smiley faces. That could be a lot of unnecessary work, though. The other thing we do is for each smiley face, we could traverse it. So say, is the first thing either a colon or a semicolon? If it is, we know we're on the right track. And then is the second thing either a dash or a tilde? If it is, we have a nose. If it's not, is it either a capital D or a smiley face? And if it was, is the next thing a capital D or a smiley face? I think I'm going to take that approach because that seems the most doable. So let's do this. So what I want to do is we'll say we'll need a place to keep track of the current count, and then we will iterate over the array, and then we will iterate over the current face. If the first character is a colon or a semicolon, great. If the second character is a dash or a tilde, great. Else, if the second character is a smiley or a capital D, cool. So if the second character was a tilde or was a dash or a tilde, we then want to check if the third character is a smiley face or a D. And then here we want to make sure that there are no more characters. So because if the second character is a smiley face or a D, and then there's a third character, we know that it's invalid. So let's just say this. Iterate over the array. Iterate over the current face if the length of the face is either 2 or 3. Because that'll just get rid of all cases where there's too much or too little. And then we should be able to take care of if it's a smiley face with a nose and a mouth. Okay. I think that's it. So if the third character is that, then we will increment count. Otherwise, if the second character is that and the length is 2, so we know that this is the last thing in the face, we will increment count. I think that should cover us. We'll see when we actually write out the code. And then lastly, we'll return the count. Okay, so place to store the count, we'll just say let count start off as 0. And then we're going to iterate over the array. So let's do a for loop. Let I equal 0 while I is less than array.length. I plus plus. Iterate over the current face if the length of the face is either 2 or 3. So let's store it in a variable. So current face. Actually, I've been calling these things like current item, current number. Let's just call this face. Like face is the face that we're looking at right now. And that's going to be array at I. Okay. If face.length is 2 or face.length is 3, then we'll do all of this. Otherwise, we know it's an invalid face because it either has too much or too little. Okay. If the first character is a colon or a semicolon, so if face at 0 is a colon, or face at 0 is a semicolon. Cool. And then all of this will be inside of the if statement here, because if the first character was neither of those things, then we know it's not a valid smiley face. Okay. If the second character is a dash or a tilde, if face at 1 is a dash, or face at 1 is a tilde, then we're going to check for the third character. Else, we want to check if the second character is a smiley face. Else, if face at 1 is a smile, or face at 1 is a big smile. So we want to check if face at 1 is either of those things, and face.length is 2. Because if the length is 2 and the second item is that, then we know we have a valid smiley face. So then we'll say count plus plus. Okay. Then if the third character is a smiley face already, so we can pretty much copy this if statement here. So we'll say if, oh no. If face at 2 is a smiley face or a D, then we will increment the count. Okay. This is pretty messy. We'll definitely clean this up, but I think the logic is there, right? So if the face is either length 2 or 3, then we're going to do all this logic. Otherwise, we immediately know it's not a smiley face. If the first character, wait, this belongs here. Yeah, if the first character is either a colon or a semicolon, we know it's a valid face. Otherwise, we're just going to keep moving. If the second character is either a nose, or if the second character is a smiley and the length is 2, increment count. But if it was a nose, then make sure that the last character is either a smiley or a parenthesis or a D, and if it was, increment the count. I think this will do it. This is really messy. We will clean this up. But let's see what we get. Let's run the sample tests. Okay, those passed. Let's do some of the other tests. And those passed too. All right, let's clean up our solution. So this one is count the smiley-faces.js. Let's create a new file. Put that in there. All right, I'm gonna leave this as is with all the comments and everything, and then I'll create like a cleaned up version below it. Whoa, did I paste it? No, I didn't. There we go. Okay, so one thing we can do is instead of doing multiple comparisons, we could like create an object that has, we'll call it like eyes, and eyes will have either colon or semicolon. So let's do that out here. So let's say eyes is an object with a colon as a property, and that's true. Oh no, that's true. Or a semicolon as a property, and that is true. So basically we can say, is the first character in there, then we know that it's valid. And let's do the same thing for noses. Noses? What's the plural of nose? I think it's noses. And noses are either a dash or a tilde. And lastly, we want mouths, and those are either a parenthesis or a capital D. The fact that I'm defining keys like this, I believe this only works in ES 2015. You didn't used to be able to do this, and the reason I'm putting it in quotes is because properties cannot start with these characters unless they're actually inside of quotes. Cool. So I have eyes, noses, and mouths, and I actually just thought of like a simplification, but let's update the solution to use these objects instead, and then we'll go with, I think, the simpler solution that I'm thinking of. Okay, so if the first character is a colon or a slash, so we'll say if eyes at face at 0, and that gets rid of that. Cool. Or if noses at face at 1, do that. What's this component? Oh, there's an extra space. And then this one will just be mouths at faces at 2. And this one will be mouths at faces, well, face at 1. Should be able to get rid of parentheses. Curly brace there. Cool. So this cleans it up just a little bit. So instead of having like those or statements, we have some nice, easier to read code. We have eyes, noses, and mouths. And if each of the things matches that, then we know that it's a valid face. But let's clean this up even more. So here's what I'm thinking. If the face length is 2, then we can just do 2 comparisons. If eyes are valid and mouths are valid. Done. And then if we do face length 3, then we have a statement with just 3 comparisons in it. So this should clean it up a lot. So let's say if face.length equals 2, then if eyes at face at 0 and mouths at face at 1, then we will, let's just get rid of all this. Then we will increment the count. So count plus plus. Else if face.length is 3, so if there's 3 of them, then we'll do this comparison. So we'll say if eyes, noses, and mouths at face at 2. And this should work too. It's a little bit cleaner because basically we're saying if the length is 2, then we know the first one should be an eye, the second one should be a mouth. Hey Brooks, welcome to the chat. Good evening. And then if it's length 3, then we'll check each one. So that should work too. Let's see if this works. Let's take a quick stretch. Whew. Cool. And I think one of the last things we might do is do a reduce instead, because we're reducing this to a count. We're taking an array and turning it into a single number. So see if this works. That works. And that works too. Cool. One thing I was thinking of is like, what if we create variables that's like eye, nose, and mouth? We're fine. We'll keep it this way. Last thing I'll do is turn this into a reduce. So you know it's a reduce because we're taking an array and turning it into a single number. So this should be as easy as, we'll say return array.reduce. The thing we are accumulating is the count, and then each thing in the array is a face. And then the count starts at 0. Cool. And then this code just goes inside the reduce. And easy as that. We do also need to return the count though. Cool. So, and we don't need that initial variable. So similar idea, we have our eyes, nose, and mouths. And if the logic matches just like before, increment the count, and then return the count every time. This is the winner. Whoa. Right. Sample tests work. attempt works. All right, drum roll for the final solution. It's trying. It's trying. Oh, it worked. Cool. All right, that was fun. Super fun. And we're only 30 minutes into the stream. Great. Plenty of time to solve these other ones. All right, this next one, scramblies. So complete the function scramble, given two strings, returns true if portion of string 1 can be rearranged to match string 2, otherwise false. So let's grab our examples here. So basically, the first string can be anything, but if anywhere in there, there's a W, there's an O, there's an R, there's an L, and there's a D, we should return true. And then this one, like Code Wars, so there's a C, O, D, E, W, A, R, S. There's a lot of other stuff too, but it does contain this word. And then this one does not contain an E, so we return false. Okay. Lots of different ways to go about this. One, I want to call it like a naive approach, is we iterate over this string, and then for every letter in here, we search this array to see if it's in there. If it is, we keep going. And basically, if every letter was found, then we return true. But the reason I don't like that is because that's multiple iterations of this second string, right? Like every time we look at the next letter, we're then searching that whole array. So to make it more efficient, what I want to do first is iterate over the first string and count all of the letters in it. So create an object that's like a count of all the letters. And then iterate over the second string and see if the object we created has that character inside of it. And if it does, decrement the count. Because one thing we probably also have to account for is what if there are multiple occurrences of a letter on the right-hand side? That means there need to be multiple occurrences on the left-hand side. Like if we look at some of their examples, yeah, like JavaScript has 2 A's in it, so the thing on the left-hand side needs to have 2 A's in it. I mean, that one's just missing A's altogether. But I think I'm going to take this approach. So basically, we will first count all of the letters in the string on the left, and then iterate over the string on the right, and make sure that it has enough in the object that we created. Okay, so here's what we'll do. So a place to store string 1 letter counts. And then we will iterate over string 1. String 1. Set a property on the object that is the current letter. If the property didn't exist, set it to 1, meaning there's only one of that letter in there. Otherwise, increment the value. Because if we see a letter again, then the value would increment to 2, etc. Okay, so we do that once and we build up an object. And then we need to iterate over the second string. So we will iterate over string 2. And if the current letter is in the object and the count is greater than 0, meaning we have at least one letter available for the current letter, then keep going. And we'll also decrement the count. So because we just saw that letter, we need to decrement the count in case there's another letter that wants that. Otherwise, else just break out of the loop. Because the moment we notice that a character over here isn't in the word over here, then we automatically know that it's false and there's no need to check the rest of the word. Uh, quick messages in the chat. Welcome, Steven. I am pumped to be here as well, and welcome, Emmy. Yeah, streaming challenges. We've gotten through quite a few. I think we got through. Oh, I guess we only got through 2 or 3. Yeah, we only got through 2 so far, but they're going well. And yeah, so this will break out of the loop and return false. Otherwise, we will return true. Okay, I hope you're following me, and if not, this will make sense once I actually start coding it up. So ultimately, what this block of code right here is going to create is an object. So ultimately, I want to end up with an object, like let's take, for example, this first case. I want to end up with an object where R has the value 1, because there's one R in it, and then K has the value 1, and then Q has the value 1, and then O has the value 1, and D has the value 1, and L has the value 1, and W has the value 1. So after this first loop, we're going to get an object that basically has the counts of all the letters in the string. Now that we have that, we're going to iterate over the second string. So just for example, we'll have that there. And then this second loop is going to iterate over world. And so for the first letter, we'll say, does this object have a W in it? Yes, it does. Let's now decrement it to 0. Go back around. Does it have an O in it? Okay, decrement that to 0. Go back around. Does it have an R in it? Yes, it does. Decrement that to 0. Does it have an L in it? Yes, it does. Decrement that to 0. Does it have a D in it? Yes, it does. Decrement that to 0. We reached the end of the word. We found everything we needed. Return true. However, if there was like a Z in here, if we said, does this object have a Z? Nope. Immediately return false. Okay. I feel like that helped anybody out there who was totally confused about what I was gabbing about. But let's make this actually work. Okay, so a place to store the counts. Let's call this letter counts. We're going to set that equal to an object. And then we will iterate over the first string. So for let I equal 0 while I is less than string 1, I plus plus. Okay, set a property on the object that is the current letter. If the property didn't exist, set it to 1. Otherwise, increment the value. So we can do this in one line of code. We could write all of this out with like if statements, but here's what we can do. We can say letter counts, and let's create a variable for the current letter. Set that to string 1 at I. And we'll say letter counts at the current letter. Let's take a quick break. This is my 5-minute timer. I'm not going to take 5 minutes, but I will take a little bit longer stretch. Okay, that's enough. If you are watching at home and you're sitting down, stand up real quick. Take a quick stretch, get the blood flowing. Okay, so current letter is from this first string, and we'll say letter counts at current letter is whatever it is. So if we've already seen it, we'll keep it the way it is, or 0. So we'll start it off at 0, and then after that, we will then increment it. So if the current letter wasn't in there before, we're going to put the current letter in there and set it to 0, and then we'll increment it. But if the current letter was in there before, we will just keep it the way it is. Maybe it already has a value like 1, and then increment that. And so this is if we have more than one of the same letter in the string. Cool. So that's doing that. Now that we have this object built up of letter counts, let's iterate over the second string. So we'll do, wait, did I tab this in? Okay, I did. Cool. It's a little weird working in the actual editor on CodeWars. Okay, so let We have another for loop. It just goes from I to string 2.length. I plus plus. And here comes the fun part. Is that right? Cool. If the current letter is in the object and the count is greater than 0. So we'll say if, and let's also create a variable for the current letter. Current letter is going to be string 2 at I. And if letter counts at current letter is greater than 0, because if it's not in there, then is undefined greater than 0? False. So if the current letter isn't in there, this is going to be false anyways. But if it is in there, then we'll make sure that it actually is greater than 0. My curly braces are off. I don't know. I might have to fix this. Steven is asking, how long have I been programming? Let's see. I built websites when I was like 13. I will be 28 in like 2 weeks. So what's the math? Quick JavaScript math. 28 minus 13. Oh, I guess I'll ask DuckDuckGo. 15. I've been programming for 15 years. When I was 13, I wasn't like really into it, but I learned like the basics of PHP and JavaScript, and then I got a degree in computer science. So I have been programming a very long time. And the past, I'm currently unemployed, but before that, for like 2.5 years, I taught programming at a place called Galvanize. So yeah, I did not realize I've been programming for 15 years. Thanks for asking that. That's a very long time. Okay. So if it was in there, we then want to take what's already there and decrement it because we've seen that letter. Is it 25? 28? No, it's only 15. Cool. So if we solve that letter, we decrement the count, meaning if the letter wasn't in the original string twice, this will work. Otherwise, the letter was not in there at all, so we can just immediately return false. Cool. And then if we made it through this whole for loop, that means every letter in the second string was in there, so then we ultimately can just return true. Okay, this is messy. We'll try to clean it up a bit, but let's see if it worked. Sample tests. Oh no! Expected true instead got false. And this is for the very first one. You know what? I'm going to bring this down locally. I think my curly braces might be off because this online editor is messing me up. Let's create a new file. What's this called? Scramblies. Yeah, something's weird. Okay. That matches with that. Oh, this needs to be length. That's why. So, okay. So the first for loop will go over the first string and create this object. And actually, let's log this object out so we can actually see like when it's running the test what this looks like. So letter counts. And then we'll return false if we didn't find it. Otherwise, we'll return true. And then let's also log the letter counts again after it's over, because what we should end up with is initially letter counts has all of the letter counts, but then after the second for loop runs, everything should be decremented because we already saw it in the second string. Okay, this should do what we want. Cool. So basically, here's what's happening. Like the first for loop creates this object. Wait, let's do this. Enhance. So the first for loop created this object, and it's a count of all the letters in the string on the left-hand side. And then after we go through, we decrement every time we see that letter from the string on the right-hand side. And if we made it this far to this second log, then that means everything was already in there. Curious if they will give us any examples where there are multiple of a single letter on the right-hand side, but it doesn't show up that many times on the left-hand side. I don't know. Let's attempt. Cool, that worked. Question in the chat, is there a way to use map to create an array of the letters in the string? What I'm thinking is we can actually turn this first for loop into a reduce, because basically we would reduce the array down to an object of counts. And then this we could reduce down to a Boolean. However, I like using a for loop here because it'll immediately break the moment that it doesn't find a letter. We could use another array method, something like all or any, which basically says, do any of these not match the condition, or do any of these do match the condition? We'll look that up, but I definitely do want to convert this to use higher order functions. So let's do that. Cool. So this first thing, I want to turn into a reduce. And the way to think about like why is this a reduce is because it's taking one array. Well, and I guess here's the other thing. It's a string. We can turn it into array pretty easily, an array pretty easily. But you can think of a string as like an array of characters. But I want to turn this array of characters into a single object. And then we'll worry about that second one later. So typically, if you want to use reduce on a string, you have to split it. So you might say string1 dot split on the empty string, which basically busts out that string into an array, dot reduce, and this will then take in letter counts, because that's our accumulator, it's the thing we're building up, and then also the current letter. And our accumulator starts off as an object, so that goes there, and basically letter counts is going to be equal to this reduce. And really, we just want to do this inside of the reduce. And then return letter counts. Let me hide that so you can see all the code. So basically, take this string, turn it into an array, and then reduce that array down to an object that will have all of the counts inside of it. Yeah, that should work. And then let's look up some other array methods, because there's basically an array method that says like, do all of the elements in the array match like this condition? Let's see. I know there's, is it any or some? Array any? Is it some? Yeah, array.proto.type.sum. A method tests whether at least one element in the array passes the test implemented by the provided function. But I want every, because I want to make sure that every element in the array has a count inside of there. So every is the one that I want. Okay, so let's use every. So here, ultimately we should be able to return this every. So return string2.split. So turn it into an array. And every. So we want to do every current letter. And basically we want to do this. Some functional programmers might be shaking a finger at me out there because I am actually modifying external state inside of this function. But we need to do that for this case. So this should be all I need for that. Because what this will say is, does every letter return true? And if every letter returns true, that means that there was a count available in the object that we created. Otherwise, the moment this returns false, I believe this will actually break out just like a break in a for loop would break out. Yeah, because if any one of these is false, then that means it's not found in the object. Okay. Let's see if this works. Sample tests. That worked. More tests. Those work too. Cool. One little trick I want to do though is, so string.split will actually turn this string into an array. I believe though I can call the prototype reduce on the string and it should still work in the same way. So that would work like this. Actually, I'll keep both so you can see them. I think this will work. Let's try it. So if I do array.prototype.reduce.call, so I want to call that on the string with that callback function. And then also the same thing with string 2. So array.prototype.call every on string 2 with that callback function. I think this will work because basically what this does is it invokes the reduce function with the string as the internal instance. And the way the reduce call works internally, I believe, is just using like bracket notation to get access to each element in what it thinks is an array. But because I'm giving it a string, bracket notation should still work. I don't know. Let's see if this works. Can't read property every of undefined. Oh, I reversed that. It should be prototype.every.call. It works. Cool. And I actually like this better than string split because in my mind, like I guess it depends on the JavaScript engine, but in my mind, a string split is an actual iteration of the string. But now by doing this, it's just a single iteration. Like the reduce is one iteration over the first string, and then the every is up to one iteration over the second string. Cool. This is great. I am proud of this solution. All right, let's do a drum roll. Attempt. Okay, I gotta submit the final. Okay, submit final. Cool, it worked. Oh, let's do a. Cool. And if we look at the top solution, they did what I did, but with smaller and uglier variable names. But basically, they first created a map of the first string, which is all the letters and their counts. And then the second one just did a iteration over the second string, make sure it's inside the map. If it's not, return false. Otherwise, decrement. I guess I could have changed that up a little bit. So like, what do they do? If it's not in there, return false. Otherwise, decrement. Yeah. Oh well. Either way will work. Cool. All right. This next one is not going to be super easy, but this is human-readable-time. So basically, you're given a total number of seconds, and you need to convert that into hours, minutes, and seconds as a string. Okay. Let's copy our examples. At least one example. Okay, here's what I'm thinking. This right here is going to be seconds divided by um, however many seconds are in an hour. And you take the, like, drop the remainder. So however many total hours are in there, that's going to be our hour number. And then with the remaining value, however minutes are left in the number of seconds, that'll be put there, and then we drop off the rest. And then whatever we drop off will be the leftover seconds. Okay, so we will get total hours by dividing seconds by, calculator please. There are 60 seconds in 1 minute, and there are 60 minutes in an hour. I know this. So 3,600, are there 3,600 seconds in an hour? Does that make sense? So 3,600 divided by 60 minutes divided by 60 is 1 second. Okay, so divided by 3,600. Get total hours by dividing seconds by 3,600. Okay. And drop the remainder. So that's the total number of hours. Is it 1,000? I think it's gotta be 60. 60 seconds in a minute. No, yeah, 60 seconds in a minute, 60 minutes in an hour. So it'd be 60 times 60. I think I'm right. Double check, please. Maybe somebody Google it. I'm getting conflicting information in the chat, but I think that's right. Drop the remainder. Okay, so then get total minutes by dividing remainder seconds by 60 and drop the remainder. And then total seconds is the previous remainder. And then we have to figure out how to format it so that it has a leading 0. Let's take a quick break. If you're watching from home, step out of your chair, maybe take a quick stretch. And yeah, last thing will be to append hours, I spelled minutes wrong, minutes and seconds in a string with a padded 0 if needed. And we'll figure out how to do that when we get there. Okay, so total hours is going to be dividing seconds by 3,600 and dropping the remainder. So let's say hours is seconds. Oh yeah, so Jason was thinking of milliseconds. And I think we only want hours, minutes, and seconds. Yeah, hours, minutes, and seconds. Okay. So seconds divided by 3,600. And then we will drop the remainder. So we can do a math.floor of that. So that should give us the total number of hours. And then if we want the remainder, we can do mod 3,600. So we could probably store it somewhere. I don't know. It's fine. Okay. And then minutes is going to be the remainder. So the remainder of seconds divided by 3,600 divided by 60 and drop that remainder. And then lastly, the minutes are just going to be that remainder. So I should probably store this in a variable. Okay. Yeah, so instead of doing hours, because this technically will give us the remainder of whatever we divided up there, and that's what's left over. Okay, I'll leave that. And then we divide. Let's see, I am missing a parenthesis. I want a parenthesis there. So we then take whatever was left over and divide that by 60. That's going to give us the total number of minutes. And we drop the remainder there. And then lastly, seconds is going to be, this will be seconds, the remainder of the division of 3,600. For whatever reason, I'm not very good at math right now, but what I want to do is just do minutes times 60. I guess technically we could have done that here. Because minutes times 60 would give us back the total number of seconds, and then this was the seconds that were eat up by getting the hours out of it, so that should give us the total number of seconds. Phew, this is messy. I'll try to clean it up after we get the right numbers. And then we need to put it into a string. So let's just Google real quick. JavaScript pad number with leading 0. I think there's a built-in way to do it. They wrote a pad function. Don't like that. I don't like that. Is there not a built-in way to do it? Left pad. Yes, ES8, we have a new method, pad start and pad end. I'm curious if we have access to that. So we basically want to pad the start 1. Let's try it real quick. So if I had 1 and I do pad start with 1, 0, that didn't work. 2, yes, cool. But, so yeah, so if I do that, that works. But what if we have a number that is already 2 characters, like 22? That still works. Hopefully we can use pad start. Let's use that. Okay. So here, we just want to return a template literal that is hours.pad start 2. And then minutes. Oh, but this is for a string. We'd have to convert it to a string. And we'll do minutes, pad start 2. Actually, let's write a simple little function. Pad number. This will take in the number, convert it to a string, and then pad it with 1, 0. So I should just be able to use that multiple times. So pad number hours, pad number minutes, and then lastly we will pad the number of seconds. Let's see what I messed up. What do we get? Sample tests. Seconds has already been declared. Oh, because I'm overwriting it here. Let's call this total seconds left. Let's call should call this total seconds, because that's what it is. Okay. Missing after argument list. Oh, I'm missing a curly parenthesis right there. Number.string is not a function. No, it's not. It's toString. I'm messing up all over the place. Pad start is not a function. Okay, so the for whatever reason, however Code Wars is running our code, they don't have pad start. However, let me see if this works locally, and if it does, then we'll just implement a padding function. Human-readable-time is what we want. And basically, we want to test all of these, but we can just do a console.log of those. Okay, let's try it. Node human readable time. Our code works, but Code Wars does not give us access to the pad start function. So got to implement it ourselves. Let's see. You know what? We can do some super simple logic, because like all of these solutions are like iterating to see how many to add, but our little function right here could do that for us. Here's what we'll do. We'll say if number dot toString. Let's actually just store this right. So let's say const number string is number dot toString. And we'll say if number string dot length is equal to 1. Let's make this a let. We'll say number string equals a leading 0 plus the current value. And then we'll just return number string. So if the length was 2, we don't need to pad it. But if the length is 1, then we'll pad it at the beginning with 0. That should still work. Simple little solution. Yeah, look at that. Beautiful. Cool. Okay. Let's run this on Code Wars, and then I want to clean up this math, because like we're doing things multiple times. It should be a little bit cleaner than that. Sample tests. Those worked. More tests. Those work too. Cool. Oh, can I not switch to node 8 at the top? Cool. Yeah, that'll probably do it. Good call, Pijo. And so if I do this, that will actually give me access to, it should give me access to pad start. Cool. I'm going to do that. Can I go back to the solution where I had that? Okay, let's try this, and then we'll switch the node version on Code Wars. Node with Babel. Wait, it's not highlighted though. Maybe because I've already started. Yeah, maybe it's because I already started. What if I reset? Yes, reset. No. Won't let me choose version 8. I don't know if there's anything special I have to do. Oh well. Back to the way it was. There. Cool. Yeah, maybe I'll try it on the next one. I'm not sure why it won't let me switch. Okay, but let's make my math better. So let's do, well, I don't know. Oh yeah, so P2 in the chat is saying like different questions have different runtime supported. Yeah. For whatever reason, I don't like this because I kind of just want to have like a running total. Like, if I did total seconds divided by 3600, and then we could set total seconds equal to total seconds mod 3600. So like the total seconds are being reduced. Cool. And then here, total seconds would be total seconds mod 60, or like the remainder of 60. And that actually just gives us our leftovers, so I don't have to do this. Yeah, that's why I wanted to clean this up. I think this will still work. Because yeah, so now we have like a running total. So we get our hours, we then get the remainder, we get our minutes, and then the remainder of that should be the leftover number of seconds. Let's make sure this works locally still. Yeah, that still works. Okay, I like this math a little bit better. Sample tests. It works. Attempt. It works. All right, drum roll, please. Drum roll. Submit final. Is it working? It's working. It's trying real hard. I need the Jeopardy sound on my soundboard. Do 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 do. Cool, it worked. Yeah, they did a similar thing. Seconds mod 3600, seconds divided by 60 mod 660, and I guess parse int, because it parses it as an integer, will drop any of the decimal. Pito is saying no offense, but I kind of want to hear the fail sound effect once tonight. I got you. The moment my tests fail, I will actually play it. I guess they failed a few times, but I didn't play it. I should have. Definitely should have. All right, now on to one that was suggested by Mr. Chad. If you're still out there watching, Chad, the maximum sum subarray problem. So I actually did some research on this, and there is a Wikipedia article dedicated to this problem. Let me find it real quick. And they actually give you the algorithm for solving it. I want to solve it like the brute force way, which is kind of what I just deduced by deciding to do it. And then in here, yeah, so Kadane's algorithm will solve it in a single iteration, and we'll do that after I do the solution that I came up with. But basically, you are given an array, and you want to find the maximum sum of every subarray. So a subarray is any internal number of elements. So -2 and 1 is a subarray, 1, -3 and 4 is a subarray, -3, 4, -1 is a subarray. That whole thing is a subarray. Basically, the solution that I'm going to do is like a brute force solution. So it's literally going to calculate every single subarray, sum every single one, and then figure out which is the maximum sum. Hey, Brett, welcome to the stream. Afternoon. Chad is here. He's ready. Cool. So let's do this. And actually, because this one interested me, I already wrote out the pseudocode for it, but here's the idea. We will iterate from the beginning of the array to the end of the array. So that's our outer loop. Then we'll have an inner loop that goes from the current I value to the end of the array. And then we'll have a third loop inside of that that goes from I to j. And inside of there is where we're basically calculating every subarray, and we're going to sum all of those. We'll be keeping track of what is the maximum sum, and if the sum that we just calculated in this subarray is greater than that, we'll return that sum. One thing to note about this is it says if the list is made up of only negative numbers, return 0 instead. So the minimum possible sum it's saying is 0. So we're never going to have like a really like negative sum. Pijo said he got this one for Google. It didn't go so hot live. Like, it was really hard for me because I've thought about it, like really hard for me to figure out how to do it without like a triply nested for loop, because this is like a not like the solution that I'm about to do is not very efficient, because on really large arrays that's in cubed complexity, because it has to iterate once, iterate again, and then iterate another time. But then I'll show Candane's algorithm, which is pretty genius. I don't even know if I fully understand it, but we'll see. Okay, so first we will have a place to store the max sum, and we'll initialize that to 0. So we start off maximum sum is 0. All right, iterate from 0 to the end of the array, and we'll call this variable I. So we'll have a for loop, let I equal 0, while I is less than array.length, I plus plus. And that's our for loop there. And then we will iterate from the current index I. So let j equal I. So it's going to start at the current index and go to the end of the array, while j is less than array.length, j plus plus. That, okay. And then lastly, we're going to iterate from I to j with like yet another variable. So first we need, and this inner for loop is where we're actually going to calculate the sum, because this inner for loop is where we're getting access to each subarray. So first we need a place to store the sum of the current subarray. So we can say current sum, we'll initialize that to 0. We'll iterate from I to j. So we need yet another, let's tab this in one, yet another for loop that goes from k equals I, while k is less than j, k plus plus. And in here, we're going to add on to the current sum, and this if statement will go outside the for loop. Whoa, that was the wrong thing. Okay. Let me do this. Hopefully nothing's going wrong over there. I keep pressing buttons and it's like affecting my screen over there. Okay. So here we will sum the numbers. So basically we'll say current sum plus equal array at k. So the current value in the array, we'll add that onto current sum. This for loop right here is essentially going to calculate the sum of every single subarray. But after we're done with one iteration of that, we will say if the current sum is greater than the maximum sum, then maximum sum will be the current sum. And so basically, this is like a brute force algorithm, because we're calculating every single possible subarray sum, and then at the end of all of it, we've figured out which is the maximum one, and at the end of all of this iteration, we'll just return max sum, and that should be the largest sum. To really like visualize this, let's do this. Let's call this like subarray, and that's there. And then here we're going to push the current value into the subarray. Subarray.push. Oh, that's not right. Cool. So push the current value into the subarray, And then after the for loop, let's just log the subarray and the current sum, which will be the sum of that subarray. So we should see a ton of logs, every possible subarray and every possible sum. Let's see it happen. Sample tests. It is not showing my, okay, there we go. So you'll notice I'm calculating every possible subarray. So -2, the sum of an array with -2 is -2. -2 and 1, the sum of that is -1. -2, 1, and -3, the sum of that is -4. So this is the subarray from the beginning of the array all the way to the end. And then we need the subarrays inside of that. So like just 1 and 3, just 1, 3, and 4. And so there's a lot of computation happening here. Basically, every possible subarray gets created and every possible sum gets created. And this works. It's just not at all efficient because there's so much calculation that has to happen. Let's just do an attempt and see if it works. It might time out. Should work on random arrays, maximum buffer size reach. Yeah, so well, actually, if I don't do this internal array, maybe it will work, because this array that I was creating was actually using up more memory because it had to actually create those arrays. Let's try it without that. It still broke. Should work on random arrays. Expected 101 instead got 98. Let's double check. So our outer loop goes from 0 to the end of the array. The inner loop goes from what I currently is to the end of the array. And then the inner loop goes from I, whatever I is, to the current value of j. I'm curious why that's not working though. There's like one case where it's not working. Oh, there's several. Expected 232 instead got 195. Let's just do this. If our max sum is 98, let's log the array. I just want to see when and why it's failing. Oh, they're totally random. So that's not gonna work. Expected 80 instead got 44. It's working on the example. I'm curious why it would break with random arrays though. Am I doing this right? If current sum, which is what was calculated in there, is greater than our maximum sum is the current sum. Anybody see any errors in my logic? Like, why would this be failing for certain random things? I'm just seeing if I can get it to log. Okay, here we go. So, wait, what? I'm not modifying the array, am I? Oh, that's this one. This one failed because the maximum should, if an array of length 1, the maximum should just be that value, but apparently I'm not calculating that. Does this need to go from j to I? No, this should be from I to j because I is on the left-hand side. But it seems like the one case where we could just initialize the max sum as the first value in the array. Let's see what happens. That's still failing. Okay, I'm not going to. Something is wrong here. I will keep this solution, but I am going to attempt to do this in a single iteration. I have some pseudocode for that. Let's leave this here. Cool. And this is Kandane's algorithm, so we'll give it a try. Here. So we need a place to keep track of the current sum and initialize it to 0. So we'll say let current sum equal 0. And right, we also need a place to keep track of the max sum. Let max sum and initialize that to 0. We then iterate over the array. Nice little for loop. Let I equals 0 while I is less than array.length. I believe the way this works is kind of like a running average. Not a running average, like a running total sum of the subarrays. So the first step is set the current sum to be the max. So current sum is going to be math.max of current sum plus the current number. So the current number is going to be array at I. And so current sum will be the max of current number plus current sum. Let's take a quick break. We'll do current sum plus current number and 0. So basically, like if the addition of the two was negative, we always want a positive sum, so we're just going to reset it back to 0. And then set the max sum to be math.max of current sum and max sum. So I think basically anytime an addition happens that puts it below 0, we just reset it and then keep on adding from there. And yeah, basically if we encountered any negative numbers and they like brought the value down, we'll just reset it to 0 and basically start summing again from there. And then lastly, we just return the max sum. And that should do it. That's his algorithm. Let's see if it works. Sample tests. So it works for the sample. For the full attempt, it works for the full attempt. I have no idea why my this one is breaking for the full attempt. If anyone watching from home has any ideas, please let me know. I am going to move on because I have been streaming for close to an hour and a half, and I've got one more problem to do. That's going to be a tricky one, but we're hanging in there. We're solving code katas. And this is super interesting. So what I just wrote here is if we look at the maximum subarray problem, this is Kandane's algorithm. I think this is written in Python, but basically it's like a rolling max where anytime the addition goes below 0, you just reset it because we don't care about anything that was below 0 anyways. Cool. And if Yeah, if you think about it, if all of the numbers in the array are positive, then the maximum sum is the sum of the entire array. So this would never get reset. Cool. Cool. I'll see you later, Steven. So Steven says he's enrolled in a C#.NET bootcamp. Very cool. But yeah, I'll see you next time. Okay, I'm going to call it on that one. I'll submit this solution, submit final. And actually, Pijo asked for it. I should have done the... So for whatever reason, my triple for loop didn't work. Cool. All right. Last one. This is a surprisingly tricky one. Submitted by Cassandra Goose. If you're out there watching, Cassandra, say hello. Or leave a comment if you come back and watch later. But on the surface, it seems very simple. So given the string representations of two integers, return the string representation of the sum of those two integers. So for example, if you're given 1 and 2 as a string, you should get back the string 3. Now, if you've been programming in JavaScript for more than a few months, you probably know how you might try to solve this. So one thing we can do is we can actually convert both A and B into numbers. So I could say turn A into a number, add that to B, and then we want this to be a string. So I could take that whole result and say to string. Easy enough, right? Wrong. If you think this, you'd be very wrong. So this should work for small numbers. And if we do the sample tests, great. But on their larger attempt, check this out. When they attempt to add two really large numbers, in JavaScript, if you do this, you get scientific notation. But they want you to give back the full number. And there's no way I know of tricking JavaScript into not using scientific notation. So what we're going to do is we're going to implement addition with like carrying numbers, right? Carrying the 1 and then adding, you know what I mean? Okay, it's going to be great. All right. Yes. All right. Okay. So we'll just comment this out. This only works for smaller numbers. Okay, but if we think about how addition works with like carrying numbers and all that good stuff. Full cam, okay. So let's say, and actually let's do it with their example. 1, 2, 3, and 4, 5, 6. So with basic addition, if I want to add 123 and 456, can you see that? Let me grab a marker. Okay, so 123, 456. Basic addition, 6 plus 3 is 9. Fine. 5 plus 2 is 7. 4 plus 1 is 5. The answer is 579, and that's what we have there. Great. But what if we have to carry some numbers? So what if I do like 8, 7, 6 plus 5, 4, 3, 345. Okay. This involves carrying the 1. So 6 plus 5 is 11. So you do 1 and then you carry the 1. And then 7 plus 4 is 11. 7, 8, 9, 10, 11. Plus 1 is 12. So you do 2 and you carry the 1. 8 plus 3 is 11. 8, 9, 10, 11. Plus 1 is 12. And so the answer is 1221. So what we're going to do... Oh, hey, Cassandra. Welcome to the stream. But what we're going to do is we're going to take these two strings and add them one at a time. And if there involves a carry, we'll have something to hold on to whatever number we're carrying, and then we'll add the next number. Let's do it. Okay. Take a sip of my tea. Remember to switch back to the smaller cam because last time I forgot. There we go. So here's what we do. We are going to, we'll iterate up to the length of the longer number, and we'll do all the addition there, because if one string is longer than the other, after we're done with all of the addition, whatever's left over just gets put onto the front of that. So we will iterate the length of the, we'll iterate the length of the shorter number. Okay. We will add the current number in each number. If the result is greater than 9, we will store the carry in a variable somewhere. And lastly, we will append the sum of the current numbers to the result. And we actually we want to prepend, because as we move along in the sum, we're like going to be prepending a number to the beginning of that final number. Append the sum of the current numbers to the result, and I'll say prepend. And here we'll say if the numbers were not the same length. Oh, this could get tricky though, because what I was thinking is we could just pin the rest of the number. But what if we said 999 plus 1? That actually requires a lot of carrying. So we say 9 plus 1 is 10, carry the 1. 9 plus 1 is 10, carry the 1. 9 plus 1 is 10. So we really need to iterate the length of the entire, the longer one, because that's going to help us keep track of carries. And we are going to be iterating from the right to the left. Iterate the length of the longer number. Let's just start writing some code. Okay. So let's say longest length is just going to be math.max of a.length and b.length. Okay, so whatever the length of either of them are, longest length will be the longer one. So in the case of like 999 and 1, the longest length is 3. And I realize you cannot see the code. Now you can see the code. Okay, so we grab the longer length and then iterate the length of the longer number in reverse, because we want to go from the right to the left because we're going to be adding the places there. We also need a place to store the sum, and we'll initialize that as just an empty string. I remember to switch it back, Chad. Cool. So we will, this is where we're going to keep track of the sum. Cool. Iterate the length of the longer number in reverse. So I'm going to have a for loop. We're going to say let I equal longest length minus 1, because that will be the indice of the thing all the way on the far right, while I is greater than or equal to 0. I don't know if you can hear it, but there's some really loud motorcycles outside my window. I minus minus. Okay. So this will, let's take for example, the length of this one was 3, so that would have been the longer length. We would then start our iteration at 2, because 0, 1, 2 would be the indice of this. And actually, I want both of these strings to be the same length, because when I'm accessing indices, I don't want to have to do any weird math. I want to say like this number bracket 2 should give me 1. I think that's what I'm going to do. I'm going to pad, if there is a shorter number, I'm going to pad it with zeros so that all of our indices are the same. Cool. Yeah, thanks for watching, Emmy. And Chad says, learning lots of great cases for math.max. It's a good thing. I mean, it's a pretty simple algorithm. Like, if one is greater than the other, set that variable, but it just does it right in line for you. But here's what I want to do. We'll say, if a.length is not equal to b.length, then, or here, let's do this. If a.length is less than b.length, then we're going to pad the front of a with zeros. Else, if b.length is less than a.length, then we're going to pad the front of b with zeros. So we'll just say, while a.length is not equal to b.length, a equals 0 plus a. So that's going to put a 0 in the front of it. And then we want to do the same thing with b. So this should give us 2 numbers of the same length. One of them is just going to have zeros padded on the front of it. Cool. And now we can just do a.length, because both of them are now the same length up until this point. I want to run this locally because I want to make sure we're doing the right thing. So what's this one called? Some strings as numbers. Let's create a new file, some strings as numbers.js. I'm going to do this, and let's just log, if we do some strings with 999 and 1, what do we get? Actually, let's just run the function, and then right here, I'm just going to log A and B. And if we've done everything right, then A and B, well, 1 should have like a bunch of zeros in front of it, and we need to pass in strings. Cool. So let's do node some strings as numbers. That works. Okay, on the right track. So now at this point, both of them are the same length. So let's actually store the sum here. Okay, and so we're going to iterate from the end, and we're going to add the current number in each number. So we're going to say, we'll say num is going to be a brackets I, and we want to turn that into a number so that we can add it. So I'm just going to use a plus sign, and this will be a single digit, so that'll be fine. And then we'll have b at I, so this will be the b number. Add the current number in each number. So we'll say I don't know what we should call this, simple sum or like current sum. Let's just call this inner sum. And this is going to be a num plus b num. And if the result is greater than 9, store the carry. And actually, we should be adding the carry here too. So let's say let carry start off as 0. And when we add them together, we also want to add the number that we carried. And if the result is greater than 9, store the carry. So if the inner sum is greater than 9, then we'll say the carry will be 10 minus the inner sum. And prepend the sum of the current numbers. Okay, so let's think about this. Like in this example, we did 9 plus 1. So 9 would be the A num and 1 would be the B num. So 9 plus 1 is going to give us 10. So 10 is the inner sum. And if we do 10 minus the inner sum, wait. We want to grab the tens digit and the ones digit, and we carry the ones digit. So I won't do subtraction. I'll do this. I'll do inner sum mod 10, because if we do the remainder of the division of, and no, this isn't going to be the carry. This is going to be this is the number that we prepend to it. So let's call this this is essentially the number that's going to be put into the place of the final number. So let's just call this place num. And initially it's just inner sum, because if inner sum was less than 9, it stays the same. Otherwise, place sum is going to be the remainder of the division of 10. Because I'll show the code. I'm sorry, I'm hiding the code right now. But 9 and 1 is 10. And so if we do 10 mod 10, that's 0. So now the place number is going to be 0. And then if we did that number divided by 10, that would give us the number that we're going to carry. So place num, oh no, oh yeah, let's hide my cam, back to there. And so place num is going to be that, and the carry is going to be inner sum divided by 10. And we'll do a math.floor, because we basically just want the tens place. Okay, so store the carry, and then prepend the sum of the current numbers to the results. So here we're going to say sum is going to be place num plus the current value of sum. So that will prepend it, and sum should be a let variable. And then lastly, we will return the sum. If this works, my goodness, I will be proud of myself. Okay, let's just log this. And we're going to expect that to be 1,000. Oh, we might have to do, no, I guess we shouldn't. I think if there is a carry, we need to put that on the end. That might be an issue here. Let's see what happens. Yeah, so we've the last step is to take whatever was carried and put it on the beginning of sum. So carry plus sum. And basically, if there wasn't a carry, then we're going to reinitialize carry to just be the empty string. Okay. This is fun. We basically just implemented an adder from scratch. 1,000, cool. But let's take some really big numbers like 999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 if you were to represent this in JavaScript, I believe you just get like mathematical notation. Like I did this. Yeah, 1 plus. But if we use our now awesome adder, we should get a number with a bunch of zeros on it. Let's see what we get. Yes! Oh my god. Okay. Yeah, and so Brooks says he stepped away. It sounds like we're implementing big int. We are implementing however what's the largest number of characters a string can hold? That's the biggest numbers that we can add together now. This is exciting. Okay, let's run it. Because Brooks, basically, let's show the problem real quick. They give us two strings, and we need to add those strings together to get a resulting string number. But we can't just do this. Like, this is what we tried initially. But for really big numbers, it shows scientific notation. So we have to do it manually. Let's try it. Sample tests. Okay, so it works for the sample. All right. This is exciting. I'm excited. Are you excited? Drum roll, please. I know what went wrong. Or... Oh, we totally forgot. Because we're putting zeros on the front of it, we need to drop those off at the end. So it expected 8670, but it saw 8670 with a 0 at the beginning. So all we have to do is in our final result, get rid of the zeros on the end of our result. Cool. Let's see the examples though. So 00103 and 08567. Cassandra Ray with the emoji. Are you freaking out because I solved it? I'm excited. I am very excited. But basically, we implemented an adder from scratch. We're carrying the one manually. It's beautiful. I mean, one way we can do this is basically just say, once we finally have the solution, if it has any zeros at the front of it, remove them. I think that's what we'll do. So let's just say sum is that, and then lastly, we'll say while sum at 0 is equal to 0, sum, oh no, stop it. Sum.slice 1. So if the first value in sum was a 0, remove it, and keep doing that until all of the values at the beginning that are zeros are gone, and then return sum. Hopefully this doesn't break other cases. Let's see. Sample tests. Works for the basic one. That deserves... Okay, drum roll for the final submission. Wait. Drum roll. Okay. It's still going. More drum roll. More drum roll. And I also ranked up to 5Q. Very cool. We did it. So, yeah, that was awesome. Okay. I could have cleaned up the solution, but I have been streaming for 1 hour and 47, so I do want to end it there. But that was really fun. We basically took the maths that we do in elementary school with like carrying the ones, and we implemented that with JavaScript. We carried the one, we added, it's beautiful, beautiful thing. I just saw though, like on some of the previous solutions, this also would have worked, like reversing the numbers, because what we did is we went from the right to the left. But if you initially reverse the numbers and then just add them in that way, that would do it. Cool. Cool. And Cassandra said she joined the Coding Garden clan. Good shout out. So if you go to your, I think, account settings, you can set your clan to be Coding Garden, and then we can compare and rank up together. I believe if we go to like social, we can see other Coding Garden people out there in the world. It's loading. Cool. So there's Chad. He's in the chat right now. Heck, I think that's Cassandra. Wemo, we've seen him in the chat before. Who else? Pijo has the same picture as. Oh, maybe that's like a default picture. But there's also Ska. I think I've seen him in the chat before too. Kaizen, he's a regular on the show. There's Bob. He's a regular too. Cool, yeah. So if you want to join the clan, just throw the word Coding Garden in your clan name and you can join up. I will push up all of my solutions from today up to GitHub. The only issue we had today was with this maximum subarray-sum. For whatever reason, my like nested loops weren't working, but Candane's algorithm did work, so that was fun. But as I mentioned, there is a GitHub repo. I'll push up all of my solutions there. And if you have any suggestions for what I should do next Wednesday, I do this very same stream every Wednesday at 8:20 p.m. Mountain Time. You can throw a comment here on GitHub, or throw a comment in the description of this video as to a kata that you would like me to solve. This was extremely fun. Thanks everyone, Chad and Cassandra, for suggesting the ones that I did this time. And if you want to see me solve some other ones, please suggest them as well. Have a wonderful afternoon, morning, night, evening, wherever you are in the world, and I will see you next time.